Hey everyone, let's get into the demo of Infoblox Threat Defense Detection Mode for Microsoft DNS. Why Microsoft DNS Threat Defense Detection Mode? You don't need any NIOS or NIOS-X in place to get started. It connects directly to your Microsoft domain controller, so your team can be up and running without touching your existing setup. Effortless setup. No project window needed. It just reads a log file, no resolution changes, no DNS disruption, proof of concept up in minutes, torn down just as fast. True client IP visibility. Here's something your security team is going to love. This surfaces the actual client IP and asset name directly from Microsoft DNS, while the user information can be correlated through the Microsoft Active Directory discovery job, giving your team complete end-to-end visibility. Share via ecosystem integrations. Once your team sees the detections, sharing them is seamless. This plugs into your existing ecosystem tools so findings go straight to the people who need them, no extra steps. Compare versus your existing stack. Already running any DNS security vendors like Zscaler or Palo Alto? Keep them. The solution sits alongside your existing tools and shows exactly what they're missing versus what we catch, a direct comparison your team can put in front of leadership. Zero DNS architecture changes. We know your DNS setup isn't something you want to touch. With this, you don't have to. It observes quietly alongside what you already have. No hops, no latency, nothing reconfigured. Test DFP policy before you block. Before your team flips the switch to block anything, run new DFP policies in detection-only mode first. You'll see exactly what would have been blocked. No surprises, no angry tickets, no unintended outages. In short, Microsoft Threat Defense Detection Mode turns DNS from a blind spot into a powerful security signal. How Microsoft DNS TDDM works. I'll show how Microsoft TDDM works from MS DNS logs all the way to threat detections in Infoblox Threat Defense. We start with the DNS server. Each Microsoft DNS server on a domain controller writes very detailed DNS reply events into the DNS Analytical ETW channel. That gives us all the raw DNS telemetry we need without touching the live query path. A PowerShell script collects these logs and forwards them to a central Windows Event Collector, or WEC, so all DNS activity is aggregated in one place. At the WEC, the Infoblox agent parses and normalizes the data, then securely sends it to the Infoblox cloud. In the Threat Defense Cloud, we apply threat intelligence and analytics to detect malicious activity, all with full client attribution. We're not changing DNS. We're simply adding visibility and context on top of it. Now, let me show you how this looks in action. In this setup, I have three main components: a domain controller, a Windows Event Collector, and a client machine, all joined to the same domain. Let's quickly verify that. On the Windows server, you can see the domain techblue.co, with DC1 as the domain controller. And in the workstation, we have the client machine testing windows and the WEC server, both domain joined. Also, on the WEC server, you can verify the full device name, confirming that it is part of the same domain. Next step is enabling DNS analytical login. For that, we run a PowerShell script on the Active Directory server where the DNS role is installed. What this script does is, it enables DNS analytical event logging and forwards those logs to the WEC server. There are two supported options for running the script. Option 1, run the script manually on each DNS server. Option 2, configure a group policy object to run the script at DNS server startup. For this demo, I used manual approach. You can download this script from the deployment guide. Once downloaded, run it as administrator, providing the WEC server name is required. After running the script, you can verify that it is running in the background using the PowerShell command shown here. Now let's move to the Infoblox Universal Agent installation on the WEC server. Go to the Infoblox portal. Configure Administration-Downloads Universal DDI Agent. Download the agent. And install it on the WEC server and join to the Infoblox portal using the join token. Once installed, you can verify that the services are active on the WEC server. Also from the Infoblox UI, navigate to Configure-Service Deployment, Universal DDI Agent. You should see the agent status is online. Next step is mapping the agent to a security policy. Navigate to Configure Security Policy. You can either create a new policy or clone the default one. Then, set the network scope to Infoblox Agent. And select your agent.
And save it.
And complete the policy creation. Once the policy is created, a discovery job will automatically be triggered. To verify that, go to Configure Networking Discovery On-Prem. You should see a job with Type DNS log events. Associated with your agent, make sure it is enabled and in green state. Now that the configuration is complete, let's look at the results. From the client machine, I am querying some malicious and legitimate domains, where DNS is pointing to the Windows server. In the security activity reports, you can see that the malicious domains are detected, but there is no enforcement. The action is shown as block detect only. This is the key behavior of detection mode, visibility without impact. Similarly, in the DNS reports, you can see the query domains being logged. Now, you might be wondering, how is the user information getting correlated? That's because, along with detection mode, I have also enabled the Microsoft AD Discovery job, which maps IP addresses to user identities. That's it for this demo. Thank you.